give you the go. So let's see.
It says we're live.
It does say we're live. So
Ready
hang on.
to go.
Let me just double check on the Facebook page. Should be popping up here shortly. I think we are good to go. Live. Okay. All right, Lou, have at it.
All right. Well, welcome everybody. My name is Lou Merloni, and we're sitting here today. I'm also joined with Patrick J. Sweeney, who's the author of Fear is Fuel, a new book. You got to go out there and check it out. And joining the two of us here is Dr. Earl MIller. He's a professor in the Department of Brain and Cognitive Sciences at MIT. Runs a Miller Lab at the Picower Institute, PhD in psychology, neuroscience, as one of the top 5 most cited papers in neuroscience. So these two are the professionals. A little bit outside of my world a little bit, but I love it because I'm learning something new each and every day. So, gentlemen, welcome. Dr. Miller, thanks for joining us.
Thank you. Please call me Earl.
I will. Okay, Earl. Well, first off, this is in this chapter here, chapter 9 of the book, talked a lot about volitional control. So I'm just going to start off and let you get into it. What exactly it is, how do you study it, discover it?
Well, what is volitional control? Well, what volition isn't, it isn't it isn't reacting to the environment. It isn't just reacting to a stimulus. Like if I throw a rock at your head, you're going to duck out of the way. If you touch something hot, you're going to withdraw your hand. That's not volition. Volition is decision-making, not reacting. You study it by looking at what's called context-dependent behavior. So a great example of that is you act differently whether you're listening to a lecture in a lecture hall or at Fenway watching the Red Sox. You're going to behave differently. You're going to behave differently in a fancy restaurant versus a Subway or whatever fast food joint. You know, in everyday terms, you change your behavior, you act appropriately for the circumstance at hand. And that's where volition comes in, our ability to adapt our behavior to what we think is appropriate and will get us to our goals in a given situation.
So when you say, Earl, when you're talking about volitional control as a choice, what about a choice to overcome things? And we can use Lou as an example. You said throw a rock at his head. He's had a lot of guys. He's had a lot of guys throw rocks at his head. They happen to be wrapped in leather, but he's willingly doing something that goes completely against what your natural instinct and everything that about survival, and that the amygdala is telling you don't stand in front of that rock that's hurling at your head. So how does volition come into maybe overriding or overcoming the amygdala, the limbic system, the area where where fear rests for us and where fear starts?
Yeah, exactly. I mean, that's an example of this context-dependent behavior, is that you change what you do. You can override even these instinctual reactions if you know you have a different idea, different goal. If you're playing baseball and people are supposed to be throwing hard things at your head, you can know not to react to that and stand and catch the rock. You change your behavior. You can suppress these reflexive reactions to if the suppression of the reaction is appropriate for the task at hand. So the way to think about it is that these emotions, these reactions come from our very primitive parts of our brain, so-called reptile brains. We have a thing called an amygdala, which you know about, you wrote about extensively in your book, that produces these kind of emotional reactions like fear. But then what the higher animals like humans have evolved is something called the cerebral cortex. And the cerebral cortex is the top part of your brain with all the folds and the lines and stuff like that. And that's the more advanced part of your brain. And the way to think about your cortex, your cerebral cortex, it's sort of an add-on to your primitive brain. Your primitive brain evolved to do these very simple things like react to the environment, react emotionally, reflexively, and then your cortex is an add-on which allows you to do things like change your course of action. So if you may have a moment of fear, but your cortex tells you, oh, it's okay, I don't need to be scared. Or I can go into a dangerous situation if I think I need to achieve something.
So a lot of times in this book, Patrick, we talks about prior beliefs, and I'm just curious, as far as you talk about creating solutions, is that kind of what we have to do? We have to go back to some of the prior beliefs and create new solutions? when we face fear in some of these situations you're talking about?
Oh yeah, I mean, a lot of our behavior is based on these our experiences, biases from our experiences, and it helps to revisit those experiences and rework them to change your priors, if you will, to change your behavior. Remind yourself of what's important. That's the funny thing about memory in the brain is you remember things, and then every time you think about those memories, bring those memories to recall them, think about them consciously. You don't just like recall it and then put it back where it was before. You recall it, and as you think about it, you change those memories. The memories go into what's called a labile or plastic state. And when you think about those old memories, you rework them a little bit and change them. And then when you put them away, they're stored in this changed form. So you could literally change your past memories, and your past memories will allow you to change your future behavior by changing your past memories.
That's pretty trippy to think about. That's one of the things that we talk about is going back to your fear frontier and those traumas you had as a child. And then you're exactly right, that reworking the memory and the emotional memory that's associated with that semantic memory, right? We have two memories, and one we can change, the other we can't, if I'm not mistaken, but we can change the emotional part. And then you're saying that influences our future. It might be an interesting time to talk about how our subconscious decision-making starts to come into play, because, there's a fairly robust debate, I think, that's still going on within neuroscience about a study that was done down in Texas a while ago about free will. And do we actually make decisions, or is it all subconsciously happening and then we justify it with our biases? Is there any update and anything there in terms of kind of the free will debate and how volition comes into that?
Well, I mean, you would be amazed at how much of your decision making takes place really on the unconscious level. And the reason is a very simple reason for that is our conscious minds are very limited in capacity. Humans are very single-minded. We can think about one or two things at any one time. And because there's limited capacity, because our conscious minds are so narrow, and by the way, is in sharp contrast to our long-term. We can store a lifetime of memories and experiences in our head in a latent long-term memory format, but for some reason, we only can think about one or two things at the same time. So a lot of even everyday decisions, they depend on weighing so many factors simultaneously that it's beyond the capacity of your conscious mind. So a lot of decision-making gets done at the level of unconsciousness, and then it gets reported to your conscious mind as like a gut feeling. So for an example, that either you guys play poker?
No, sure.
Oh, yeah.
Yeah, poker, for example. A lot of times decision making in poker is, do I call, do I raise, do I fold? It's all based on this gut feeling of what the person in front of you has. And there's some conscious decision making going on there and what you think their hand is versus your hand. But a lot of it are all these a multitude of factors, past experiences, your own biases towards how much risk averse you are. There's so many factors that they're too much for your conscious mind to process. So it gets processed on an unconscious level where all these things can sort of be weighed against one another in some giant statistical table you have in your unconscious brain. And then it gets reported to your brain as a gut feeling of what to do. Consciousness is really good for, talking about consciousness, having conversations like we're having. Consciousness is good for that. It's also good for making plans before you actually go out and do something. But a lot of our day-to-day walking around decision-making is taking place on an unconscious level, and consciousness is sort of like along for the ride. It's kind of after the fact.
So there was part of this too in this chapter I wanted to ask you about, because Patrick had talked about Cato an awful lot in this, and there's 3 rules to live by, and I'm wondering how they relate or connect to volition or controlling your life. They prepare for the worst, love your neighbor, and imagine your death. Does it connect to volition and controlling your life? Those 3 philosophies.
We could connect that to overcoming fear, because so you have these primitive parts of the brain that produce these reflexive reactions, like I'm going to feel afraid, but you have this more complex, more advanced cortex, especially your prefrontal cortex, which is behind your forehead, the most advanced part of your brain. It can countermand these fear actions. Like you feel fear, and then your brain can say, "Oh, it's okay because I know I have this additional information I can take down. It's okay," or maybe there's a need to be courageous. Well, the same thing happens with it's not just like happening after the fact. You have an emotional reaction, then your your advanced brain says, wait, slow down a minute. You can also preload your brain to prepare for fearful situations, to load Cato's principles in your brain. Remind yourself, one of the things humans are really, really good at above every other animal is we're really good at projecting ourselves into the future. We can think about what's going to happen 5, 10, 15, a whole lifetime ahead of us. Most animals are very short-sighted when it comes to future plans. So we can preload these principles, these guidelines, these things that can help us overcome fear when the fear comes along and channel it in the right direction.
So one of the things that's interesting about channeling it in the right direction is we've had a lot of people who say about kids particularly, if you're feeling upset, if you're feeling strange, and one of the things we talk about in the chapter is, well, go to your safe place. We'll try and make you happy, and we'll make everything okay for you. And what that isn't doing, what that robs them of is the chance to learn how to develop these defense mechanisms and that sort of thing. How does a developing brain, sort of fit into what you're talking about, Earl?
Well, I'm not a child psychologist or even a clinical psychologist for that matter, but I would think that dealing with the situation is better than avoiding it. Now, the thing about your brain is very, very plastic. It's especially plastic. I mean, it changes all the time. So you think about certain things, you think about certain ways, those pathways, those networks in your brain that are activated when you're thinking in a certain way, they get strengthened. And if you avoid certain thoughts, the pathways, the connections in your brain that correspond to those thoughts that you don't think about for a long time, they weaken. So your brain literally changes itself by thinking. So practicing a certain mode of thought, practicing dealing with situations, practicing dealing with difficult situations, having that kind of practice will strengthen those pathways in the brain that deal with them successfully. So in the future, when you're out in the real world and something happens you need to deal with, your brain is more prepared, you've done the pre-processing and strengthening needing to deal with those situations.
And that's, sorry, Lou, go ahead.
No, go ahead. It's all right.
That's one of the things that I bring to light in the book. Almost everybody at some point or another has heard about the amygdala, the fear center. It handles the fight, flight, or freeze, and we all know that, especially at this point in the book. But one thing that people haven't heard of is the subgenial anterior cingulate cortex, or the SGACC, because that's the courage center. Maybe it's because it's too tough to say. But the SGACC, we don't get that fully developed until the prefrontal cortex is developed, correct? And so it's not till our 20s that we really have a courage center?
That's correct. Well, our brain isn't fully developed. The anterior prefrontal cortex, executive parts of your brain, cingulate, don't fully develop until you're about your early to mid 20s, which I think is a pretty good reason to raise the driving age to like 25. I'm amazed I survived my adolescence, I got to tell you. Your brain isn't fully developed into that age, so you don't have that ability to not have just act based on reflexive emotional responses. So, for example, a good example of this is, so when we talk about volition, we're talking about decision making, deliberate action, choosing among alternative pathways how to act in a given situation. That's what your frontal cortex does, and that's what develops last in the human brain when you're in your 20s. When you don't have that, you become a creature that just reacts to the environment in a often inappropriate way. So, for example, people with damage to their prefrontal cortex, they have a certain syndrome called stimulus-bound behavior, where they react to things reflexively. They can't stop themselves. So maybe you walk into a room where a person with this brain damage in their frontal cortex is sitting at a table, and you're drinking a cup of coffee or something, and you set it down on the table, the cup of coffee, and the person will just reach over and grab the coffee and start drinking. Now, why do they do that? Because cup, drink, it's a reflexive reaction. It's a natural association. When you see a cup, you drink it. But having a more developed, advanced part of your brain, you know that based on the rules of our society, and that's what your frontal cortex does. It absorbs all the rules of our society to know what's appropriate and what's inappropriate. Having a fully developed part of this brain, which again doesn't develop until your mid-20s, you know what's appropriate and safe and a good course of action in a given situation. When you have damage to that part of the brain, that's all gone. All those filters, all those inhibitions are gone, and you just become a creature that just reacts to the environment. Now, I'm not saying that younger adolescents are like these brain damaged patients, but there's some.
You
Continuum on there, and I experience on that.
So what I was going to jump in and ask you, because you start talking about preparing for the worst sometimes, and that can help you. And Patrick and I have had this discussion about me, myself, like in a career. I was at a point in my career where things weren't going well, and I finally just sort of gave up and said, worst thing that could happen is this is my last year playing pro ball. My life's going to be okay. And that freedom, knowing that, saying that out loud, allowed me to go play at a level that in the minor leagues got me to the big leagues. On the flip side of that, and I want to know if there's a difference between these two things, because Patrick and I have talked about this as well. If a manager hits me on the way up to the plate and says, hey, whatever you do, don't strike out. And that's my thought. That's the worst case scenario. I'm going to strike out. Like, it's like I can't imagine the worst case because a lot of times the pitching coach is like, hey, don't walk this guy. Whatever you do, you're probably going to walk this guy. Is there a difference between letting the negative control you and almost creating the action?
Well, one's a more long-term deliberative process where you prepare yourself well in advance, knowing you can have these, you have to, if you imagine the worst case scenario in the future, it gives you some peace now knowing that even that's not so bad. But in the heat of the moment, that's kind of a different situation. You've just activated your amygdala. You don't have the time and the to really deliberately overcome and gradually suppress those negative thoughts. In the heat of the moment, it's hard to gain control of things, especially when you're in a highly charged situation, like you're stepping up to the plate at Fenway. So that's a little, it takes time and practice to like prepare your mind for the worst and channel things in the right direction when the time comes. In the heat of the moment, it's often more difficult.
And so how do you make it easier in the heat of the moment then?
Practice at it. You just got to practice. Your brain will get better and better if you keep channeling your thoughts along the same line. Practice calming yourself, and it's all these like things, a lot of our brain's reactions to emotions often feed off of our bodies, like our heart starts racing, start sweating, and then your brain gets in this positive feedback loop with your brain where you start panicking more and more because your body's telling you something's wrong and something must be wrong. Oh my God. And, then it gets worse and worse. So, practicing things like, deep breathing exercises, practicing on calming your body can help a long way to break that positive feedback loop with your brain.
It makes perfect sense. So now, Earl, you're famous for your study on multitasking. I know you thought I was going to go with bass playing, but no, multitasking. And you've got some really interesting things because my wife, my kids, half the employees I had when I was running my tech companies would say, no, I'm really good at multitasking. So
everybody does that.
What's that?
Everyone thinks they're good at multitasking. No one is good at multitasking. No one. See, the weird thing about your conscious mind is it's very, very limited in capacity. You really are like, our thoughts are very, very narrow. We only can think about one or two thoughts simultaneously. Now, a good example of this is perception. Like right now, you guys, everybody out there has a feeling that the way their brain works, the way they see things is like their brain is like a video camera with a wide angle lens. You see everything that's in front of you. It's not actually what's going on. What's going on is your eye is moving around 4 times a second, taking in little bits of the world in little tiny, narrow little snapshots. Then your brain pieces together these snapshots into this illusion that we're seeing everything that's in front of us. And I can show you you can see demonstrations of this online. You could see flip between 2 pictures where something huge like a tree is appearing and disappearing, and people will take minutes to find it. And if you could really see what everything is in front of you, you should find it right away. Instead, you don't. Or you listeners out there, or viewers, do a Google search on the gorilla test. And
I remember that.
Yeah. I mean, things happen you're just completely unaware of because our conscious mind is so narrow, we have this illusion that it's wide. So when you think you're multitasking, what you're actually doing is task switching. Your brain is switching back and forth between the 2 tasks or 2 or 3 or whatever tasks, alternating. It's doing it very, very quickly, but your brain papers this over into making you think you're doing more than one thing at once. So big deal. What's the problem with that? The problem with that is it takes time for your brain to reconfigure. It takes like a second or more for the circuits in your brain to reconfigure from one task to another. And while it's reconfiguring, what's going on is your brain has to, first of all, when you switch from one task to another, you have to backtrack a little bit. You have to then error correct, figure out where you were. And it happens very quickly, but it takes time. And that means all this critical time you could be spent thinking focusing on the job at hand, getting more done, you're spending the time switching. And that's just a waste of productivity.
So how do you approach that in your life? Is it just one thing at a time? That's it.
One
And
thing
that
at a
way you be
time.
more efficient.
Yes, try to monotask. That's the thing about multitasking. The reason it's a kind of sounds like a paradox. That's something we're so bad at, we all want to do. Well, if we're so bad at it, why do we want to do it so much? Even I want to do it. Everybody wants to do it. And the reason is because our brains evolved in a different environment. Our brains evolved in an environment that had much less information. And any little bit of information might be very, very important. Like a rustling in the bushes might mean a tiger is about to leap out at you. So our brains evolved this craving for new information, because new information might be life or death. So our brains evolved this craving for new information, but they also evolved in a world where there's less information. So we also evolved this narrow-mindedness. But now in the modern world, these two things together, our brain didn't evolve to deal with this incredible thirst for new information and so much information available. Now it just becomes a distraction. So what do? You can't just overcome this tendency to want to multitask just by force of will. It's just too hard to overcome that thirst for knowledge. So you got to plan ahead. Say, I'm going to set a timer and I'm going to do nothing but work on this one project for the next 20 minutes, half an hour, and then I can check my email. Remove this, so schedule that. And if you practice doing that, your brain being like a muscle, the more you practice that, the better you get at it, the more natural it will be. So carve out times to monotask, then let yourself check the email or check YouTube or whatever. The other thing you could do is remove distractions. A lot of people have these workstations set up where they have multiple screens. Usually one or two of those screens have work on, and the rest are like, cat videos on YouTube or Facebook or whatnot. Get rid of those extra screens, remove the distraction, and if it's not there, you won't want to keep checking it out. And the other brain, and lots of studies have shown that you're more efficient, your work is better quality, and you get more done if you monotask instead of trying to multitask. And
sorry, go ahead.
I'll say, so one last tip, one last brain hack you could do is that if you're trying to focus on one thing at a time and you find your mind wandering, get up and walk around for 5 minutes. It raises your heart rate, increases blood flow to your brain, oxygenates your brain, gives you a little bit of a refresh.
So in this new world that we're going to be emerging to with a lot more working from home, it's going to be tougher to narrow down the distractions. For leaders out there who might be either leading a company or have a team that they work with, what kind of suggestions would you do for things like this? Right, this is the new normal where people are doing Zoom calls or working from home and multitasking. How do you limit? How do you force yourself to limit the distractions in that situation?
Well, all you can do is just eliminate as many distractions as you possibly can. I've never had a job at an office in my life, so I'm not an expert, but you could do things like not require employees to respond instantaneously email, so they constantly have to be checking email or constantly pinging them on this and that. Leave people alone. Let them do their job for a while without bothering them. Don't be a distraction.
Schedule some focus time.
Schedule focus time. Yeah, that's the whole thing. Is you got to plan ahead and schedule time to monotask, and your work will improve. And this isn't just me. There's numerous studies showing this. And I'll give you another little statistic, is that a lot of people out there are thinking, that's for somebody else. I'm really, really good at multitasking. Like you said, your wife and your daughter. Nobody is good at multitasking. In fact, there's an inverse correlation. The people who think they're the best at multitasking, lab and test them, they're actually the worst at it. And it's for a simple reason. The people who multitask a lot are people who they can't help themselves. They just do it because they can't focus. They can't ignore the distractions. So they rationalize it to themselves by saying, "Oh, I can do it. I do it a lot, so I must be good at it." They make themselves feel good about themselves by convincing themselves they're really good at something which they're actually really quite bad at. And the one thing the brain is really good at, it's deluding itself.
That's for sure.
So I was curious, given, like Patrick was saying, what's going on right now, given what you do for a living, where is your mind right now? How do you say people to deal with this? Volitional control, trying to feel like what we're focusing on, create different solutions, given with the coronavirus and what the world is dealing with.
Yeah, I mean, that's a big question. It's more a question about mental health than anything else. keeping focused at the, just keep in mind that what I try to do this, I'm not speaking as a neuroscientist now, but as a person, I keep in mind that we'll get through this. We've gotten through 1918 flu epidemic and 2 world wars, and we'll just keep your focus on the long term, because we'll get through this eventually, and then everything will be better.
So one quick question that popped up about about focus. Someone's sitting here working, they like to have music on in the background, and I don't know if it's classical music. You're a musician, but whatever kind of music it is on the background, because it feels to some people that they can focus better. Why is that?
I'm glad you brought that up, because when I talk about multitasking, I'm not talking about 2 things going on at the same time. When I say multitask, I mean 2 cognitive demanding tasks. Try and do 2 things that require focus and attention. If you can have music on in the background, it doesn't grab your attention, that's perfectly fine. It can actually be kind of a meditative thing, because sometimes when it's too quiet, you're listening for things that will distract you. I listen to music all day long when I work, but listening to music is not a cognitive demanding task. I don't need to devote much thought to it. It can be there in the background. But one thing I can't do is when I listen to, we record our bands, we record all of our rehearsals and practices, and I can't listen to recordings of me playing while I'm working, because now I'm listening for things like, should I play this differently? That engages me too much. So that I can't listen to. That's something that requires focus. But just walking and chewing gum are not cognitive demanding tasks. You could do that while you're thinking also.
Any new research you guys are working on in your lab that is interesting and people might want to hear about?
Yeah, a few things. I mean, one thing we're very interested in these limitations of cognitive capacity, why our conscious mind is so limited. And actually, one of the things, so I do basic research, but occasionally something practical falls out of basic research, which is kind of a nice thing about basic research. When scientists talk about basic versus practical research, or clinical versus basic research, clinical research is like something that's I'm working on some problems on drug that's going to have a solution like right now or next few years. Basic research is the same thing, but like on a 20-year time scale. You're doing things now that will help human health farther down the road, but could have a greater impact. You're learning more basic stuff about how the brain or the body works. But occasionally something practical falls out of it. Like, for example, when I talked about this visual perception thing we have, where we're taking in the world little bits at a time, we made a discovery a few years ago that I'm still surprised at, and that your ability to perceive things in your line of sight is not even. People have different hot spots and cool spots where they perceive things better, faster, have a higher capacity, and cool spots where they have we're actually pretty bad at perception. So if you look
based on where they look.
Well, if you look straight ahead, keep your eyes still. So every time you move your eye around, you're fixating, your eye is fixed on something. Then you can think about when your eye's still, you have the right versus left, or up versus down, or upper right versus upper left. It used to be thought for many decades, in fact, I was trained, that your ability to take in information was even across your whole line of sight. What we discovered is that actually different people have different hot spots and cool spots. Some people are way better at seeing things when they're in their upper right visual field versus lower left. Some people are really good at the upper left and really bad at the lower right. We didn't expect that, but it was there, and so now we're working on. I have the company where we patented this test where we take subjects in, give them a quick 5-minute, 10-minute test. We have a heat map of where you perceive well, where you perceive poorly, where you have a hot spot, where you have a cool spot. And Lou, let me ask you, if you pay $65 million for a new Red Sox outfielder, don't you want to know whether they're a little better on the right versus left, or better at seeing an up versus down? Because if you know where your hot spots and weak spots are, you can mitigate that by changing your behavior, like reminding yourself. You actually train yourself. We've shown this with our app. You can, by getting feedback on where you're strong, where you're weak, you can help even that out a little bit. And what happens is your brain starts moving your eyes in ways to compensate for your weaknesses. So now all of a sudden you're seeing things more evenly across the field. Well, it's also good for team building. Like say about a football team, you want people who are strong on the right to be on the left side of the field. People who are strong on the left, stuff like that.
See, I needed to when I was playing, because I couldn't hit anything up. So obviously I had a problem seeing things up. I was low ball hitter. So
hey, well,
that might help me.
Doctor, You can't tell anyone in baseball yet, because Lou, I can see the wheels turning. Lou is thinking about making a comeback. We get him on your software for about 6 months, and he's ready.
Maybe softball.
Yeah. That's it takes a long time, but your brain can gradually figure this out. We can just really speed up the process. But so for example, for years, I've limited myself to 2 computer screens. There's one where I have whatever I'm working on, and one where I have like some science graphics or something, so I can refer to the 2. And for years, I've always had one screen in front of me and one on the left, never a screen on the right. It just never felt right to me. When we made this discovery, I did my test. I discovered that I'm much better at perceiving things on the left versus right. So my brain gradually figured out not to put stuff on the right because it doesn't like it there.
Yeah.
Or people will tell me things like, when I go to listen to a lecture when at college, I always sit on the right side of the room, left side. I feel like I learn better when I'm on the right side of the room versus the left side of the room. Stuff like that.
You never knew. Now they know.
Yeah.
Now they know why.
So I think one last question I have for you, Doc. You're also involved with some research with Nielsen and some other folks. How is neuroscience getting into the commercial world or the corporate world, either in research and product design, and how is it making its way mainstream that people might see, that our listeners might get a taste of?
Well, it's you can measure the brain responses to different things like products and see which ones are more effective or less effective. So, like the Nielsen example, Nielsen Neuroscience was a company I was involved in. They had, if you put electrodes on people's heads, measure their brain waves. There's a certain signature called gamma, which is about 35 hertz or higher frequency brain waves. They go off when you're paying attention to something. So they did things like they showed people TV commercials and figured out when people were showing this reaction from these high frequency gamma waves in their brains. And when they were showing that, they were paying attention. And when they weren't showing it, they weren't paying attention. So you know which commercials or which parts of which commercials were effective versus non-effective, stuff like that. You can measure. One thing you can measure really readily in the brain, as like our example of different things on different sides. You can measure how well the brain reacts to things in the outside world, how well it's focusing attention, how well it's perceiving things, and that can have implications for things like heads-up displays, for sports, for neuromarketing. It grabs people's attention versus what's not grabbing their attention.
That's fascinating stuff. You mentioned one last thing I want to make sure we touch on. Brainwaves, you mentioned that. We didn't really talk about it. People used to think brainwaves was kind of like engine exhaust, right? The engine was doing the work and it was running, and the exhaust comes out, doesn't do anything. You found something different though, didn't you?
Yeah, well, we're not the only ones, but we helped. When I was in graduate school, the brain was usually thought of as a bunch of separate little pieces, like a bunch of, like a clock with a whole bunch of gears. And if you figure out what each gear does, we can figure out what the brain does. In this case, the gears being individual brain cells and stuff. That was the way I was trained as a neuroscientist. What's become obvious over the past 20 years or so is that there's these emergent properties in the brain. The brain isn't individual parts working together. It's like they network interactions that produce these additional properties that you can't see one piece at a time. And one of those is brain waves. So it used to be thought, when we had this focus on individual brain parts, brain waves are thought of as like the humming of a car engine or the exhaust from a car engine. Well, the humming reflects whether the engine is revving high or low, but the humming doesn't help the engine work. That's the way people thought about brain waves. But now it's becoming increasingly clear that your brain is kind of like FM radio. Is that different parts of your brain, different networks in your brain, different neurons, they talk to one another by synchronizing these rhythms, by synchronizing their waves. And if they're in sync together, if they're waving together, they talk to one another. And if they're out of sync with one another, they don't talk to one another. It's how the brain regulates where traffic flows in your brain by synchronizing patterns of these brain waves, right? And we think that's why it explains this why our conscious mind is so limited. Because if the way your brain works, the way thought works is by these brain waves all synchronizing together, it means your brain is squirting packets of information around in these rhythmic waves. And that means all the thoughts you need for one current moment for your conscious mind have to fit in the side of one wave. And that's Because if your brain works by FM radio, then everything you need for one moment in time for a conscious thought has to fit. All those packets of information have to fit inside just one wave.
Huh. That's really interesting. And so how does that, if we're talking about brain waves, we talked a little bit about neuroplasticity, and the comment I always say that the neurons that fire together wire together. How does that affect, if it's wirelessly, right, kind of communicating through the brain waves, how does that affect neuroplasticity and training, the mind to be courageous, or training it to shut off the amygdala?
Yeah, good point. I mean, you're right. So fire together, wire together is how the brain makes new connections. If two neurons, two brain cells activate at the same time, give off electrical impulse at the same time, they form a connection between the two of them. And that's what you're talking about, Patrick. It's a famous saying from Donald Hebb: neurons that fire together, wire together. We've amended that. That's still true. And that's still the case. But we've added to that by neurons that hum together, temporarily wire together.
Wow.
So the way to think about it is anatomy. When I was in graduate school, again, we learned that anatomy was everything in the brain. Anatomy was destiny. Neurons talk to one another because they share a physical connection. And that's where fire together, wire together comes from. But now the way we think about it now is the anatomy in the brain, it isn't destiny, it's potential. The anatomy is like the road and highway system. It says where traffic could flow. But something else says where traffic does flow from moment to moment. And that's what these brain waves do. They are the traffic signals on the highway of your brain.
It's like Waze for your mind.
Yeah, ways for your mind. But having said that, building those roads and highways are very important. So if you build if you think about things in a positive way, you think about how to deal with fear or whatnot in a positive way, you build bigger highways that will help the traffic flow in that direction.
Yeah, that's
just that anatomy can't be everything, because our thoughts are highly flexible. So something has to determine where the traffic flows on the highways, and that's what we think the brainwaves are doing. But it doesn't take anything away from building those highways. You need those highways so the traffic can get somewhere.
Well, and I think it's amazing. It's a great thing to end on, that our brain has evolved to evolve, right? To keep changing, to keep creating new pathways and reaching higher potential. And anyone out there can do it. You don't have to be born with gifts. You don't have to have anything special. So awesome conversation. Lou, you got anything else?
Yeah, I would just like to say that I know a lot of people probably watching this maybe are in the industry and really enjoyed this conversation. But even for someone like myself who's not, and is maybe in a different part of the world, I talk about sports for a living. I'm still fascinated by it. And to be honest with you, this last 8 minutes, whatever it was fascinating. It was an honor just to be part of that discussion. So thank you, Patrick. Thank you, Earl.
Thank you.
Hello. Have you as always, Earl. Thanks so much, and thank everybody for tuning in. We'll get a recording of this up as well, and if you guys have questions, you can either shoot them to me or hit me on Facebook or Twitter or Instagram, anything, and I can track down Lou or Earl or whoever, and we can get some questions answered if you have them too. So, everyone, thank you so much, Earl. Great to catch up with you.
Thank you.
While I'm sequestered at home, I've been taking the harmonica. I'm not going to play it yet, but I want to sit in with the band for at least 1 or 2 songs in about a year.
We'll make that happen.
Awesome. Thanks, guys.
Bye, guys.
Take care.
Take it easy.
Take care.